Sorry, when you work all this out on the calculator, you should have gotten 169.6847. Okay, which means P then is 200,000 divided by 169.6847, and that will give us an answer of 1178.66 if you do that in your calculator. Okay, so there's one way to do question one, and you need to be familiar with this way. It's very important that you know a mortgage, pension, or a loan is the sum of the present values of each of the repayments. However, there is a faster way. Okay, so question one again, that's our interest rate from the previous page. The payment amount is given by this formula. Okay, on page 31 in your log tables, amortization formula for mortgages and loans. Okay, equal payments at equal intervals, where A is the annual repayment amount, P is the principal, I is the interest rate. Okay, so the payment amount is what we wanted to know. The principal, well, you borrowed 200,000 euros. Okay, the interest rate is 0.004867 times 1 plus the interest rate is 1.004867 to the power of t for us is 360, all divided by 1.004867, that's 1 plus the interest rate, to the power of t 360 minus 1. Okay, go to your calculator there and you're going to get that same value of 1178.66. Okay, now question 2 says Alice wants to take out a 20-year mortgage. The interest rate over the lifetime of the mortgage is 8% per annum. She's making repayments of 850 euros per month. What's the largest mortgage she can afford? So again, you've got this problem of an annual interest rate, but a monthly repayment. So you say 1.08 to the power of 1/12 minus 1. That gets us our interest rate. 1.08 to the power of 1/12 is that minus 1. Okay, now I didn't check this one out, so I'm going to go with an interest rate of 0.006434. I'm going to work to 4 significant figures and hope that I get the same answer as the back of the book. But if I'm out by a euro or two, you'll know why. So here's our formula. Okay, payment amount is 850 euros. The principal is what we want. How much of a mortgage can she afford? Our interest rate here is 0.006434. Okay, multiplied by 1 plus the interest rate is 1.006434, all to the power of t. Well, she is paying for a 20-year mortgage, so that is 240 months of repayments. Sorry, I put that really in the wrong place, didn't I? All divided by 1 plus the interest rate is 1.006434 to the power of, again, 240 minus 1. Okay, so let's see what we get here. 850 equals P times, okay, so that's 0.006434 times 1.006434 divided by, now I need to put this in brackets, 1.006434 to the power of 240. I left that out over here. That was to the power of 240. Put that in brackets, to the power of 240, and then the minus 1 comes in. That's why the brackets need to be on that denominator. So I get 0.00819 1479. I'll take every decimal place there. So P then is 850 divided by that number. So that is 850 divided by the answer I just got. So she can afford a mortgage of 103 euros 766 103,766 euros. It asked close to the nearest 100 euros, so that's 103,800 euros. Okay, question 5 says a woman saves 250 euros, 250,000 euros to fund a pension, and she now plans to retire. She wishes to draw down equal annual installments from these savings for the next 25 years. Now that should have actually said, installments at the end of each year. Okay, and I'm going to explain to you now when you can use the formula and when you can't. Assuming a 5% interest rate, calculate the value of each yearly installment. Okay, so this is 5% annual interest, yearly installments, so we can work with that 5%. So the value of her pension, the amount she saved, is equal to the present value of each of the payments that she's going to get. That assumes that this first payment happens after 1 year. Okay, that the present value of that first payment is 1 year. Otherwise, what we're going to see now is that when you work that out, you get a first term of P over 1.05. But otherwise, your term would not be P over 1.05. Okay, so were it the case that she was taking her first payment of the mortgage on the day she of the pension on the day she retires, you wouldn't be allowed to use this formula. It's only if she's taking each payment at the end of a payment period, and that's equally true for loans and for mortgage. This formula only works at the end of the payment period. So there's the first term in the geometric series. The common ratio is 1.05, and you've got 25 terms. Okay, so using the sum of geometric series formula, you'll say the amount of money she has saved, the sum of all of her repayments, is of the present values of all of her repayments, is A times 1 minus R to the power of 25 all over 1 minus R. And if you do that, you get 250 is P times 14.09, so dividing through, she can afford an annual payment at the end of each year of 17,738. Okay, she doesn't get that until a year after she retires. Doing it again using the formula, it is an awful lot faster. You're going to say, well, what's our annual repayment? The principal is 250,000. Okay, the interest rate here is 0.05 or 5%. 1 plus the interest rate, 1.05, all to the power of 25 for 25 years of repayments, divided by 1.05, 1 plus the interest rate to the power of 25 minus 1. Okay, and if you go and do that in your calculator, you're going to get yourself the same answer, 17,738 euros 11 cents. Okay, thanks for that.